Hi, I'm Dave Kassler, amateur radio call sign KE0OG, and hello to Augies Worldwide. I've been having some antenna trouble, and I was really trying to troubleshoot it with the Rig Expert. It's my butternut HF9V, and it just needs to be taken down and completely rebuilt because it's been bending too much in the wind, and the joints have become loose and so on. Now, as it turns out, I have a very nice MFJ hex beam, which covers 20 through 10. And the band that is uncovered right now for voice work is 40. I need a 40-meter dipole. So that's what I'm going to make today, a 40-meter dipole. We'll make it, and we'll put it up on the roof and go from there. So we're going to make a dipole, a 40-meter dipole, something quick and dirty, except that when you make dipoles, they can last forever and take lots of power. So the first thing to do is measure the wire. I get this wire down at Home Depot. It is stranded 12-gauge wire and 500 feet. And the reason I got this is because for the price for 100 feet, which would be fine for a 40-meter dipole, it cost half of what this cost. And I figured, well, good grief, I can get a whole bunch more wire out of that. And then that way, in the future, which I'm sure will come, I will make more dipoles. If nothing else, I can use it for radios. So let's get this off here. Okay. Here we go. Now we need two pieces, each 35 feet long. And the way we're going to do that is to measure them out. I'm just going to use the trailer here as a handy hitch point. And we're going to measure from here. Now this is stranded THNN wire, which means it's house wire, which also means that it's soft-drawn copper. So we'll just put this to the same place. It's soft-drawn copper, so it will stretch with time. But we're not going to worry terribly about that because I'm going to leave the ends on the thing. If anything, that would mean that the resonant frequency would go down as the antenna got longer. Okay, so let's take this and put it in here. And pull this at the same time. We want oh, that's only, whoops, 15 feet. $30, $35. Now 35 feet is too long, of course, but we're going to use the extra to wrap it back around itself. Okay, let's just make it 36 feet. And we've got some extra. You know, it's a lot easier to cut wire than it is to solder on an end. So, let's get our second piece of wire. This is insulated wire. The insulated wire does make a little bit of difference in the length of the antenna. Not very much, but enough to be measurable. So the extra insulation actually creates a slightly lower velocity factor in the wire. Right there. All right, we've cut our wire. Now the next step is going to be to solder the, or rather, we're going to put end insulators on this and then wrap the wire back around it. And we'll put in the center, which will be an insulator and a place we can connect the coax. So that's what we have to do for now. Okay, so after measuring the wires, I've got the 2 wires lying on the floor here in the shack, spread all over the place. And what we're going to do first is put on the center insulator. What we need are an insulator for each end here. And so I've got these little dog bone insulators I picked up at a ham fest. And then we need an SO239 because I want to be able to attach a length of coax to this and fix it as time may go. So the first thing we're going to do is take the ends of this wire. Now we measured the wire and from right here. Okay, so this is extra here. And so here's what we're going to do. We're going to take this end of this wire and put it over here like this, bring it down, and very carefully wrap this a couple good times around here. Okay, and then we're going to take the other wire and do sort of the opposite kind of a wrap so they won't tend to unwrap each other. We don't want the thing to unwrap on us. Okay, so this is pretty good and tight. Maybe I'll give it one more turn on each end. And now we're going to solder these to the little connector. This is an SO239 connector, and it connects to a normal coax. And so we're going to solder one of these leads to a corner here and the other lead to this center lead right here. Now the wire I'm using is number 12 stranded. It's 7 strands. It's soft copper, so it's going to stretch a bit. But let's just take it like about right there. And I've got a tool here that will strip that. And this is number 12 wire, so we'll put it in the number 12 hole, and we're actually going to want something fairly long. So we'll go like that. Yeah, maybe we'll come under like that. Okay. Keep that good and stranded together. And we're going to put that through the corner here and bring it back on itself so it can be wrapped around. And some pliers here that can get a hold of that. And just wrap that right on around like that. And then this way we can put some solder in that. I put the biggest, heaviest tip I've got on the soldering iron, so let's turn the soldering iron on. Okay, and then while we're doing that, we'll get this edge of the wire ready over here by cutting it right there. And we're not going to strip it near as far here, because it just sort of sticks into this little thing here like that. Okay, so first let's get this one soldered. Now, a little tool here that kind of holds things. Like I said, kind of holds things. And you know, it's going to be easier if we can hold that wire in one place. So I'm going to tape this down here. Now another thing I'm going to do, I've got a dental pick that is right here. And what I'm going to do with the dental pick is just touch it with a little bit of flux. Okay. Right around this area here. Just a little tiny bit of flux. That will make it easier to solder that to that. Okay? Now, this trick I've used is just using packing tape for putting, holding the wires down. Is something I've used for years. Okay, the tip claims it's hot. Let's see if that's really true. Here's some fairly thick solder. Oh yeah, very nice. Okay, so let's apply this over here and see how we can do. Okay. Done. Now that's the center, okay? Now what we're going to have to do is measure the length of the thing, and we want to get our dimensions exactly right. And I wrote these down in my logbook. Here's my logbook. I want 7.2 megahertz, okay, and for 65 feet total, so that's 32.5 feet per side. And we're going to take this outside and measure it from the center of this insulator here. And then we're just going to attach these and wrap the wire back around itself. And then we're ready to put it up. Okay, we've got the two pieces of wire stretched out here, one for each side. We just a few minutes ago soldered the connector on to the top of it. Now we want to preset these for 32.5 feet, 32 feet 6 inches each. And then we're going to put in an insulator and wrap the wire back around it. So I'll get the tape measure out here and we'll see what we can do. Rolling back a lot more on this than I thought I would be. So what I'm going to do is put this through one of these insulators, and right here at the bend, wrap it back on itself. We'll just twist that around like that. This last little bit I'm going to just kind of bend it a little bit more so it won't just fall off. There, okay. And we'll do the same thing with the other. We'll just take this last little piece and kind of wrap it around a little more so that it won't come apart. Okay, there's our dipole. The dipole itself is finished. Now we have to put it up into the air. I'm going to attach one end up on the roof, and I'm going to attach the other end to a tree or pole or something out on the other end. Looks like a thundercloud is coming in. I'd better hurry up. Okay, so where are we with the dipole? Well, I put the thing up and it didn't work. I got up on the roof, which was a stupid thing to do because I had a heck of a time getting down. The older I get, the harder it is to twist myself around on that ladder and get up on the roof. So I won't be doing that again. What I should have done was taken two pieces of aluminum fence top rail and put them end to end, set those up at each end of the dipole, put some guys on them, and so on. I tried for something quick and dirty didn't work. I found out what happened. So let's take a look at that. And then after it's fixed, let's take a look at what we have and how it works. When I put up the antenna analyzer, this is what I got. The blue band across here is the 40-meter ham band, and you can see that at the low end of the band it's 2.5 to 1, and up at the high end of the band it's close to 5 to 1. This is no good, especially since it has a real nice low here at 6.75 megahertz. Well, obviously the antenna is too long by a fair amount, so let's see if we can figure out what happened here. First, let's look at some math. This is the general formula, a standard half-wave wire dipole, so lambda over 2, with a velocity factor of 0.95, which is the velocity factor for wire in general. It doesn't take into account whether it is insulated or not. Okay, is 468 divided by the frequency in megahertz to give you half a wavelength. Now, what we have here is it should be 65.5 feet long, but it's actually resonating at 6.75 feet long, so it thinks it's 69.3 feet. So the dipole is 3.8 feet too long. That's quite a bit. Let's go to the next diagram and I'll show you what happened. This is a look at the north end of the dipole, the one that's up by the roof. See how the wire is twisted back on itself? Well, what happened when I pulled real hard on the wire to get it as tight as I could, on the other end, this stayed okay, but it slipped all the way down to here. So all the part that was wrapped around became unwrapped and went back and became part of the antenna. So that's what happened. Now, I discovered that that's what happened, and I fixed it. I took the antenna down, and on the south end, I fixed that. And here's what I came up with for SWR. This, again, slightly adjusted for size, is the 40-meter band. And you'll note that it's less than 2 to 1 across the band, has a minimum resonance here at 7130 megahertz, which actually, this being less than 2 to 1 is good all the way across the band. And so the antenna is just what it needs to be, and it works just fine. Now, this is the south end, and you'll see that I ended up, that was the only little part that was connected down here. If I had pulled any harder, it probably would have gone the other way. So I wrapped it back until it was done. This is several feet of wire. Notice that my poor insulators right here, the hole in them was too big for the rope, so I just attached the rope directly to the wire right there. And I had to do this in several steps, but it worked. Now I want to show you something that I did to the center. This right here is a knot, some sort of sailor's knot, that I put in so that this piece of rope right here takes all the stress of the weight of the coax, and then I've got that wrapped up around here. So you see that this wire coming down to the center conductor and this wire coming down over here to the shell don't have stress on them. I'm going to do a separate video, very short video, that shows how to make this rope, this knot. It grabs the coax very tightly and allows it to be tied to an insulator so that it does not pull too much on the SO239 or on the PL259 connector. This connector happens to be crimped, and I have discovered that if you put longitudinal stress on a crimped connector, it may very well come apart. I've had several come apart, so I want to keep the stress off of that. This is, by the way, RG213 cable right here. Okay, so this is a look at the entire dipole. You can see it, that's rope over there. This is the north end. Here is the south end being held up by a 20-foot pole made of 2 lengths of chain link fence top rail, which fit into each other. And so that's held up there. This is the center, the dipole feed point, and here is the coax down in the weeds. For those who are interested, our covenants prohibit landscaping. We're supposed to leave it natural. And with all the rain we had this year, whoo, there's a lot of stuff out there. I've got to trim all that down before it dries out. Okay, so I've got a slide here where we can take a look at the stakes that I use for the chain link fence top rail. I get that at Home Depot, and I get these stakes available from Home Depot also. This one happens to be 2 foot long, and it's got about 10 inches in the ground, and you can also get them in 3 foot lengths, and they're basically indestructible. A good thing to be raising the antenna with. And so it's up and it works. The proof of the pudding is in the eating, they say. Now, I don't have anything here to eat, but the proof of an antenna is in the logbook. So I tried this logbook out and just wanted to show you some of what I got. The first few I did 500 watts because I wanted to make sure that the antenna would take power and everything like that. N0F was at a part of the Campus QSO party, and REN, and I'm not sure where that is, but I worked this station with 5.9 both ways. Very, very easy to capture. Now, this next one, KB9AX, is Dan in Greenwood, Indiana, and I spoke to him for close to 30 minutes. Again, I had 500 watts in the dipole. He had a big beam, a 2-element 40-meter beam up 105 feet, so he's got major station, but we were able to keep it 5.9 all the way through. Very nice contact. After that, I did another Campus QSO party, KW8N, at Lorraine, whatever that is. It's a school, I guess. 5.9, very nice signal both ways. Again, 500 watts. And this next one was part of the Ohio QSO party. Lots going on. WZ8P, and nice signals there for that. I was having a little trouble with the RF getting into my USB connectors, so I went back to 100 watts, just dropped the antenna, and talked to Hawaii. KH6J in the county named LHN, whatever that's an abbreviation for, part of the Hawaii QSO party. And it turns out that he's a Nagi. He recognized my call and said hi, and said he is following, he's subscribing to the channel, which makes him a Nagi. Okay, then I talked to KMP from Delaware County in Ohio, part of the Ohio QSO party, again 100 watts with the dipole, nice signal both directions. And this last one that I spoke with was WC8VOA, as in Voice of America. This station is at the old VOA building outside of Dayton, and my wife and I stopped by there and visited in May when we were at the Dayton Ham Fest. And he knew me. we had met during that particular visit, and so had a very brief but very nice chat with him because he needed to get on with this contest there. So how would I say the dipole works? It works about as well as you would expect. So the dipole, now that it's properly up, and it took me a while to figure out what I had done to it, that I'd stretched it too hard and pulled that wraparound off. Once I figured that out, the dipole works great. I'm back on 40 meters. I'm very pleased with it. Now the dipole is only 20 feet up, so it's going to have a fairly high elevation angle or radiation angle, but that will do till I get that vertical all straightened out. I've heard from a manufacturer who had somehow heard that I'm having vertical trouble, and they wanted to give me one of their verticals. I wrote back to them and said, let's talk. I haven't heard back from them. I hope to in the next couple of days. So that ends this episode of Ask Dave. We've put up a 40-meter dipole. I put lots of extra detail in there so you could see all the little vagaries of it, and so that you recognize that I got frustrated too. But I finally got the thing up. So there you are. And please don't forget to go to dcastler.com/support. There's lots of different ways there you can provide financial support for the channel, from as little to as much as you want. By as little as you want, I mean $1, a $1 tip, all the way up to as much as you want. There's an opportunity there to go to Patreon. I've got the equivalent on PayPal, which has fewer fees, and have the tip jar. And then, of course, I've got the technician and the extra thumb drives up there too, and so on. So we'll see you next time. Until we next meet, 73.